So in this, we're going to do a quadratic inequality in one variable. And these are quite straightforward, but it does require a little bit of work. So in this, we have x squared minus 3x minus 4 is greater than 0. So we want to find what values of x make this true, make this statement true. So we can start by just factoring. So we know that this is minus 4 plus 1. So we know our two roots. Let's go over here and we'll make a graph. So here we have a root at 4, do another root at -1. So halfway between this, or we can use our x equals -b over 2a to find our vertex. So you can just say halfway between this point, which is going to be 3 over 2. But we can also just look at this and we can say, well, -b is positive 3 over 2 times 1. So our x component of the vertex is 3 over 2. So if we want to solve for our y component, we put that in. So we get 3 over 2 squared minus 3 times 3 over 2 minus 4. And that equals something. So then we get 9 over 4 minus, and that's 9 over 2, but I'll multiply it by 2 to get the same denominator, which is 18 over 4. And 4 is just 16 over 4. And that equals my y for the vertex. So we go through and we resolve this, and what we find is it's actually just -25 over 4. So that's -25 over 4 is my y component. And this happens at 3 over 2. So there is my vertex. So I can draw my graph in, my quadratic. And we should label the axes. That's a kind of a straight line, but that's part of the quadratics, right? It's not very curved there, but we'll live with it. So now I've got the vertex here as well, which is 3 over 2 comma -25. Sorry, that's 5 over 4. That's right here. And this is my roots. So now I just want to know what values for x does it equal or what values of x makes this statement true. So when is this greater than 0? Well, if I look at my graph, I can already see like any x value on this side or any x value over here is going to have a positive output. So I know that my x component, or what's true, is going to be over here and over here. But is it at this point? No, it's not at that point. So we'll go through. We can do this as a number line. So this is my number line of x. And my roots are at -1 and 4. I know that they're positive. This is a part of my solution set, and so is over here. But the point at 4 and -1 are not. So we can draw open circles there. Now, there's another way we can draw this. We can have -1 and 4, but we can just do half of a parentheses facing in the direction that has our solution set. So that would be also the same as this. And then we can also write it in the same way that there is this -infinity to 1 union 4 to positive infinity. And that's also our solution set. So our solution set consists of x values in these areas. So you can be over here, here, like, yeah. So we should do a test point. So let's just test 0. Zeros are always our friends, zeros and ones. So we go back and we put 0 in. So we have 0 squared minus 3 times 0 minus 4 bigger than 0. That says minus 4 is bigger than 0. That's not true. Okay, so x can't be 0, but it's not part of our solution set. So we're good. That's a quadratic inequality in one variable.